Hi everyone, welcome to this ultimate Docker crash course for 2025 designed especially for absolute beginners. As you all know that Docker has become an essential tool for modern developers, DevOps engineers and cloud professionals. Learning Docker from scratch will not only open up a world of opportunities for you but also supercharge your career in tech. So in this comprehensive full-length course, you will go from zero to Docker Hero. We will cover everything from foundational concept to hands-on real-world projects. So you not only understand Docker, but can confidently use it in your own development workflow. We will also be working with latest technologies, including Java 21, Spring Boot 3, and the newest version of Docker Desktop, ensuring that you are learning in the most latest and relevant environment. This course is completely free and open to everyone, whether you are a complete beginner with no prior Docker experience or an experienced DevOps or cloud engineer or any tech professional looking to sharpen your containerization skills. This course is built to help you level up. I am sure that by the end of this course, you will be well equipped with the knowledge and tools and confident to start building and running your own containerized applications using Docker. So what are you waiting for? Let us dive in and learn Docker from scratch with some real world projects right here in 2025. So these are some important topics which we are going to cover in sequence. First, we will see what Docker is, what Docker container is, and what is the exact difference in between the Docker and the Docker container. Next, we will see what is the difference in between the virtual machine and the Docker. Next, we are going to see how we can install the Docker. In this, I will show you how you can install the latest version of Docker Desktop step by step, and in that process I will also show you how you can install other subsystems like WSL and how you can enable the virtualization, how you can check whether the virtualization is enabled or not. In case if it is not enabled, how you can enable the virtualization. I will tell you all those in this step. Next, I am show you how you can create an account with the Docker Hub. So what is the Docker Hub? A Docker Hub is a cloud-based registry service provided by the Docker. By default, the Docker is pointing to this Docker Hub for pulling the images and pushing the images to. Unless we have defined some other registry, the Docker will keep on pointing to Docker Hub by default. Now, in short, what all custom images or custom images we create or any public images, that all reside inside the Docker Hub. Next, after that, we are going to see some main Docker commands. In this, I will show you what are the important Docker commands we can use and how we can pull the images from the Docker Hub and how we can run the container using these commands, and how we can check the logs for the containers which are running inside the Docker Desktop. Next, we are going to create some custom project. Now, while creating a custom project, you can choose any technology and create a project. So I am going to choose the Spring Boot 3 and create a new project with Spring Boot from scratch. And in that, we are going to use H2 database, and we are going to create one controller with some endpoint we will for the employees subsystem. So in this, we will create a Spring Boot project with some endpoints, and once we complete the project, we are going to test those endpoints with the Postman to verify whether the endpoints are working as expected or not. Now, once we complete our Spring Boot project, we need to Dockerize it. For that, we are going to create one Docker file, and inside that Docker file, we are going to include the Docker container definition. So we are going to include the content so that the Docker engine will come to know how it is going to create a container out of that Docker file. So what all things we mention inside the Docker file, accordingly the Docker engine will create a container. So we are going to see how we can create a Docker container, what all things how we can create a Docker file, what all things we need to mention in that, and we can build our project, and how we can create a Docker image from our project using some commands like Docker build. We are going to see that. And once we create the Docker image using Docker build command, we need to run the container. So in the last step, we are going to see how we can run the container for that image, and that image contains everything like runtime and the code and application libraries, config tools, and it will package everything inside that image so that the containers run in isolated environment and unaware of each other. So this is the final step wherein we are running the containers for the images, and we can see the running containers in a Docker desktop. And finally, once our container is running, we need to test that using the Postman, and we can check like how whether now at this time we are running the containers. We are not running our local application in Spring Tool Suite, rather we are running the containers and we are testing for the from the Postman and checking the results for the container running, whether it is showing the same result for the endpoints which we have tested locally. So all these things we are going to cover from scratch. Apart from that, we are also going to cover like what is the port binding, like we have host port and container port, and how the host port will get mapped with the container port. So these are some points, but we are going to cover many points which are not mentioned at here. So I will request you all, so please do not forget to like, subscribe and share this video. This video is going to be very interesting, and I will request you all, please do not skip any step in between. Please do not forget to like, subscribe and share, because I need your support to grow my channel. So what is the Docker? Docker is a platform that enables developers to build, package and run applications in the lightweight portable containers that include everything the software needs to run, like code, runtime, libraries and dependencies, ensuring consistency across different environments. We have just seen what is a Docker. Now let us understand what is a Docker container. Docker container is a lightweight standalone executable package of software that includes everything needed to run a piece of software. And what it includes, like it includes everything like the code, runtime, libraries, tools and settings, all bundled together in a single unit. So this is about what is a Docker container. Now let us understand what are the important characteristics or key characteristics of the Docker container. First is isolation. Like each container run in its own isolated environment, unaware of each other. Like to achieve this isolation or separation, it uses the namespace and CG group, like control group, to provide isolation for processes, networking and file system. Next important characteristics is the lightweight. Unlike virtual machines which require full operating system, Docker containers share the host OS and the kernel, and due to which this makes containers much more resource efficient and faster to start compared to virtual machines. Next important characteristics is the portability. Like containers can run on any machine that has Docker installed, regardless of the underlying operating system and the hardware. This makes them highly portable and ensures consistency across different environments, like be it development, testing and production. It is consistent across multiple environments. Next important characteristic is ephemeral. Like containers run designed to be short-lived and disposable. Like once a container task is done, it can be stopped and removed. Like we can say any data or a state that needs to persist beyond the container's life cycle should be stored in a volume or external system. So this is the important feature that comes under the ephemeral. Like we can the containers are short-lived and we can dispose them at times, and we can, if we need be, we can restore or persist the data or the state even after the container's life cycle has been beyond the container life cycle. So this is about the important features of the Docker containers or characteristics. So we have understood what is a Docker container and what are the key characteristics of the Docker container. So we have understood what is a Docker and what is a Docker container. Now naturally the next question comes in our mind: what is the difference in between the Docker and the Docker container? Let us see that difference. Like Docker is a platform for developing, shipping and running applications, and it enables us to create, deploy and manage containers. Like Docker is a platform or tool set that allows us to build, run and manage containers, and it includes the Docker engine, the command line interface and the Docker Compose and other tools that enable container orchestration and the management. Like it is a platform that will allow us to build and package our application, and that application will include everything that like code, libraries and runtime and all its dependencies. It will include inside that application, and this provides a platform to build and package our application. What is a Docker container? Now the difference in between the Docker and Docker container, like container is a lightweight standalone executable package of a software, and it's a running instance of Docker image where our application runs in isolation. Like Docker container on the other hand, we can say it is actually running instance our application packaged in a Docker image. Like once we execute the build command, then the Docker image will get created, and like Docker, with the help of Docker build, we can create an Docker image, and when we run the Docker run command, at that time we can actually run that image, and that is a running instance of actual Docker image what we have created, and that running instance is nothing but a container in which will have a executable package, and that executable package will contain everything which is needed for that instance to be run, like the code, libraries and runtime and all the dependencies it will include. In short, if you want to understand, like I have highlighted, Docker is nothing but a platform for building and packaging our application with all its dependencies and what it needed to run our application, whereas the Docker container, it's a running instance, or we can say executable package. It's a running instance that have everything which it needs to be run. In short, like Docker is a platform to work with containers, and Docker container is an isolated environment where our application is executed. Like Docker container is a running instance which is an isolated environment where our application is executed. Like this is enough to understand the difference in between the Docker and the Docker container. This is about the difference in between the Docker and the Docker container. Similar way, we need to understand what is the difference in between the Docker and the virtual machines in order to understand Docker thoroughly. In case of virtual machine, like we have a physical computer with some hardware resources. On top of that, we have host operating system. It can be Windows, Linux or Mac OS. On top of that, we have a hypervisor layer. Basically, hypervisor is a software that allows us to create and run virtual machines on a physical computer. On top of that, we have a guest operating system, and on top of that, we have our actual application running. Through hypervisor, we can enable virtualization, and through virtualization, we can create multiple virtual machines for different platforms. Like we can create one virtual machine for Windows, one for Linux and one for Mac operating system. So this is how the virtual machine functions, and this is the basic structure of the virtual machine. In case of Docker, we have a physical computer with some hardware resources. On top of that, we have host operating system and kernel. On top of that, we have a Docker engine. So Docker engine is the core component of the Docker, designed to help developers to build, ship and run applications. Docker engine allows us to build containerized application with the help of a Docker file, and it will help us to run the containers, manage containers life cycles. For example, we can start containers, stop, delete and monitor containers. And the important components of the Docker engine, like Docker daemon, REST API and Docker CLI, these are some important components that Docker engine consists of. On top of that, we can create a Docker image, and with the help Docker image, basically it will contain everything it will package everything that an application needs to run, like it will include the runtime, the code, the config and the tools. Everything is packaged in a single unit in the form of the Docker image. And finally, the Docker image will be run using some Docker command, and it will create a container. Within that, it will run our application. Each container will share the host OS and the kernel, and each container will contain everything it needs to be run, like runtime, libraries, application and dependencies, tools and configuration. Everything it will contain in each container will contain all these things, and each container is unaware of the other containers. Each container will be isolated and will run in an independent environment. How we can isolate the containers? Like with the help of namespace and control group, we can isolate or separate the containers from each other. Now, the best thing is that with the help of this Docker, as it is sharing the host operating system and kernel, and there is no guest OS installation in case of Docker, hence it is a lightweight, and it also has portable features, like it is lightweight, and in terms of performance it is faster than the virtual machines, because it does not include the overhead of installing the guest operating system. Apart from that, it creates the containers which has everything inside that. In that sense, it is a portable, like it can run on any environment, like without making any changes, like the container or Docker image we can run or any environment, and we can see the consistent result in case of running the container. Next, we are going to install the Docker, and let us see how we can install it. Now here we can type Docker installation. And here we can type the first link, which we can click on the first link which appears. We can go down, and here you can see it's a get started. So you can click on this, get started with Docker. Now if you come down, so here you can click on this get Docker. Now here it will show all the Docker desktop installation for all the different platforms, like this is for Docker desktop for Mac, this is for Windows, and this is for Linux. Now if you click on this, it will show all the instructions how you can install the Docker desktop on Mac OS. Similar way, if you click on this Linux version, like this is the Docker desktop for Linux, and you need to follow these instructions to install it. Now we are going to install Docker desktop for Windows, so let us see what are the steps are involved in that. So here you can see this is the install Docker desktop on Windows. Now here we have three different options, like we can click on the first one so that it will start the installation. Now here it has started the installation, and it has 532 MB size. So it has started installing. So let us wait for few minutes or few seconds. Now till the time we can see what are the system requirements, like here it is a WSL2 backend, like here we need to have this version. So let us check whether we have this version. Let us open the command prompt, and we can simply type WSL. Now we can see it is not installed, so we can install it using WSL install command, or we can use this command as is. Yes, we can say yes, and it has started downloading it. It's a Windows subsystem for Linux. And this installation is, I think, completed. Okay, Windows subsystem for Linux has been installed. Now it is enabling the feature, and that's it. It has completed successfully, operation completed successfully. So first thing we are done with, like we have installed a WSL, it's a Windows subsystem for Linux. Now let us check the Windows version, like what version we are using. So we can click on this start button and click on run, and here we can use this winverge command, like it should be winverge, and it will show the what version of Windows we are using. So it's a Windows 11, so you can check with that command. Next thing, like we are done with, and these are some other, we need to turn on the WSL feature on Windows. So that is the next thing. Like here we can search for turn Windows on off features, and here we can come down and we can see for it's Windows Linux subsystem for Linux. This is the option we need to enable, and click on OK. Yes. Now it will require the restart, so we can restart it now, or we can let us check whether we have installed. Yes, the Docker installation for Windows is complete now. We can restart it once, so that it will be applicable for everything. So we can click on restart, and once it is restarted, we can check what other things we can do. Now we have successfully installed Docker by coming here at this link, and after that we have clicked on this getting started with Docker, and we have clicked on get Docker, and after that we have clicked on this Docker desktop for Windows, and here are the steps we have followed. Now we have just restarted our system. Now we can see what next we can do, like this is our Hyper-V backend we need to check for. Now we need to enable the Hyper-V for our system. So to check that, we need to go to our taskbar, task manager. You can right click it on the taskbar and go to task manager, and here you can select the CPU, and here you can see, if you go down it here, let me show you. Now here this is our CPU, and here you can see this is the virtualization, and it is enabled. Okay, so you need to check it should be enabled. This is the requirement for this, so that is the system requirement. Now let us check whether in our downloads, like we have installed Docker desktop. Now we need to double click on this so that it will get installed. So it has installed. We can do with this. So we can click on this. Windows container should only be enabled if you understand the risk for the information and docs. Okay, so now we can click on OK, as this is the default configuration, and we can click on OK button. Now it has completed the installation, and you can see the installation succeeded. Now once we have successfully installed Docker, we need to accept this, and we can see and this is the Docker desktop. This is the dashboard for it, and we can simply skip this, and we can skip this as well. Now this is the Docker desktop. We are inside, and this is these are the containers, and through which we can manage the containers, create the containers, and manage the life cycle of the containers. And we can see, like here, this is the Windows subsystem for Linux which we have enabled. This is the WSL, and this is the Docker desktop. Okay, this is the Docker desktop icon from which we can start our Docker desktop. So that's it about Docker desktop installation. Now we can check our virtualization status by opening the task manager and selecting the performance tab. Now here you can see it is showing the virtualization enabled. Now in case if it is not enabled, then what is the option we have? Like we need to go to BIOS level at boot time, and we need to enable the virtualization. And once we enable that, even if it is not showing the enabled, then you need to go to Windows, turn Windows features on off, this option, and here you can come down at here and you can select this Hyper-V, and you can check this option and click on OK. With this you will enable your virtualization level. But after enabling at BIOS level, if it is visible at here, you don't need to do anything. Now while installing the Docker desktop, we have come across this screen where we want to make a decision whether we want to allow Windows container to be used with this installation, and that depends on your use case. Like if you are developing on running the Windows specific applications, like apps that rely on Windows API or components, for example .NET framework, COM components, or IIS. So, and in case there is other scenario as well, if you have a Windows based container image, and then in that case you need to run the Docker in a Windows container mode. Okay, so in short, like unless you have a specific requirement to run Windows containers, for example legacy or .NET framework applications, you need to stick with Linux containers. They are lightweight, lighter, faster, and more widely supported. So we have successfully installed a Docker desktop. What next? Like, as we are going to create the Docker image, or we can create a number of Docker images, we need to understand where all these Docker images will get stored. In an obvious way, we need some repository wherein we can store our Docker images, so that Docker desktop will pull or push those Docker images from that repository. That's where the Docker Hub comes into the picture, because Docker desktop uses the Docker Hub as the default container registry unless we specify some other container registry. Like we can specify GitHub container registry, or we can point to AWS ECR. Unless we point to any of these registry, Docker desktop will keep on continue to pointing to Docker Hub as a repository. So what is the Docker Hub? Docker Hub is a cloud-based repository service where we can store, share, and distribute our Docker images. And we can also find the images, public images like MySQL, Nginx, and Java. We can find all those images on the Docker Hub repository we can make use of, and we can collaborate it with other containerized applications. To access the Docker Hub, we need to create an account on the Docker Hub, and we can see how we can create the Docker Hub account next. Now let us create our Docker Hub account. For that we can type the docker git Docker Hub, and we can click on the first link which appears, and here we can click on sign up, and here we can choose the personal account, and here you can provide your Gmail details or email address. So let me for example I can keep this Gmail. Next you can mention the username, like let me put something. So this username you can keep on using for future interaction with the GitHub. Instead of using the Gmail address, you can use this username to log in with the Docker Hub, and here you need to mention the password. and you can click on this send me the occasional product. So you can simply click on the sign up so that it will create an account for you. Next, once you click on sign up, here you need to select your username and click on continue button. So on the next screen, we need to enter the password. So this is the username. Here we need to enter the password. At times I am speaking the GitHub instead of Docker Hub. So please bear with me. So it should be Docker Hub. Here we need to enter the password, what we have set. And we can click on continue button. Now we have successfully launched to the Docker Hub, and this is the dashboard for the Docker Hub. Now this is our username. So with this we have successfully created the account for the Docker Hub. Now here one more thing you can observe here, we need to verify our email. So once we click on this one, it will send the verification mail on our Gmail account. We need to open that mail and verify our account. So once you verify your email address, check your email and verify your account, you will find the email verification is successful. That means we have completed all the steps which are necessary to create our Docker Hub account. So as of now, we have successfully installed our Docker desktop, and next we have created a new account on the Docker Hub side. Now let us see what are the main important Docker commands and how we can pull and run the Docker containers for the images which are there on the Docker Hub. Now this is our Docker container, Docker desktop, which is in running mode, and it is showing these are the images tab, and it is showing no images as of now, and this is the Docker containers, and it is showing no containers because we have not created any. And this is our Docker Hub main page dashboard. Now let us open our command prompt and check how we can use this. So as I shown you, this is the Docker Hub page. If it is not visible, you can see in this way. Now let me open the command prompt and I will show you how we can run the imported commands which are there. First we can cross check the Docker installation using command docker space -- version, and this command will show you the installed Docker version. Next thing, we can check for the images which are there with command docker images, and it is showing no images as of now. Now let us pull some image and run it. Now we can use the command docker run, and we can use this hello world image which is already there on the official website of the Docker Hub. You can run it. Now once we run this docker run command for this hello world image, initially it will try to find the image locally, and if it doesn't find this image locally, hello world image locally, then it will try to pull it from the Docker Hub, and finally it will run it. Now let us check the docker image command again. Now it is showing the hello world because it has pulled the image from the Docker Hub. Now it is showing it is a hello world image in the images list. Next we can check the Docker container now and see how it is showing. It's showing the hello world image, and this is the container which is running for the hello world. Seems good. Now we have successfully created a new container for the Docker image. Now if you go back to our Docker Hub, we can see this is the dashboard page, and if we scroll down, here we have lot many images which are available. Now here we have this Nginx, MySQL, these are some public images. Now let us see how we can pull the image from the Docker Hub and run into the container. So let us try it once. Now here let me clear this first, and here we can use the docker command docker run, -D is for detached mode, and -P is for mapping the port, and we can use 8080, and here is our 80. So 8080, this port is the host port, and this is the container port. And now we can give some name to our container, and we can give like it's a demo ng-inx, and here we can give the exact image name, which is ng-inx, which is available on the Docker Hub. Now we can hit the run command. Now here it will first initially try to find the image on the locally. If it doesn't find, it will try to download it from the Docker Hub. Seems good. Now it has successfully downloaded the image. Now let us check the images part, like using the Docker images. Now it should show two images, one for hello world and one for ng-inx. Seems good. Now let us check the container part, like we have two images. Seems good. This is the ng-inx, and this is the container for demo ng-inx, the name which we have given for this container. Okay, if you want to remove any container, then we can use this delete command. Let's say for hello world, if you want to remove this container, we can click on delete forever, and it will remove that container. Similar way, if you want to delete the image for respective container, we can delete this image. But make sure you should first delete the container, and then you can delete the image. Fine. Now if you want to cross check on the browser by hitting the URL like http localhost 8080, which is the host port name, and we can see welcome to ng-inx, it is showing, which is as expected. Now our image is running and container is running, and it is showing the ng-inx page. Now to understand Docker thoroughly, we need to understand what is port binding and how it works. Port binding is a process where we map a port inside the Docker container to a port on the host machine. This allows us to access services running inside the container from the outside world, like accessing a web server or database inside a container via the host IP address or the local host. Now let us take an example of this Docker run command. We are using Docker run -p, which is just to map the host port to the container port, and this is the image name. Now what is the host port? Like host port is a port on our machine where we want to access the services, and container port is a port inside the Docker container that the service is running on. Now let us go into more detail. Let us assume that we have two containers, container 1 and container 2, and container 1 has host port 8080, whereas container 2 has host port 8081. Now each container has its container port, like container 1 is running on 80 container port, whereas the container 2 is running on 80 container port. Now I have taken the identical or same container port for these two different containers, because I want to tell you that even if we give the identical or the different port name for these two containers, will do fine, because these two containers are running in two different isolated environments. So giving the identical or the different port name for these two containers will do fine, as long as we are giving the different host port, the port name, port numbers for these two containers. Now whenever we try to access this URL like localhost 8080, Docker forwards the traffic to the container's port, which is 80, where ng-inx is listening. Now Docker creates a network address translation rule that allows communication between the host and the container. This host acts as a middleman and forwarding the request to the container. This is how the port binding will work. Now we can see one container is running inside the Docker desktop. Now next thing what we can see, we can check how we can see the logs inside for this container. Now let me open one command prompt from here, and we can use a command like which is docker logs, and here we need to give our container name, which is demo ng-inx in our case. So we can give demo ng-inx, and it will show all the logs for this container. You can see it is showing logs for this container. This way we can check logs for any other container using this command. Now what if you want to go inside the container and see the files or logs? how we can do that. Now for that we can use the command docker execute exists, or we can use the interactive mode -it, and here we can give our container name, which is a demo ng inx. Now after that we can use /bin/bash to enter into the prompt. Now we are at the prompt. Now we need to use the Linux command like ls to show all the folders, and to go to log file we need to go to var folder first. After that we can check what all folders are there inside that. We can use go to log folder, and we can check the list of files and folders. Now let's say if we want to check the log of this file, what we can do, we can use cat command and use dpkg.log file, and it will show all the log inside that file. This way we can use this way we can check log for inside any other folder. Now let's say in our case, if we want to check the logs, we can go inside ng inx. Inside that we can check the files, and we can see the logs for this, like we have access.log and error.log, and we can check the log by using the cat command. This way we can check log for our container, and we can go inside the container and see any file which we want to see. Now in our next section we are going to create and dockerize our custom application. For this we need to create one custom application. So we are going to create one Spring Boot application using Spring Boot version 3, and we are going to Java version 21. So we are going to create some endpoint using the REST controller, and we are going to build our application and test it using Postman and verify whether the endpoints are working as expected. Next thing, we are going to create one Docker file, and we are going to build the Docker image out of it, and we are going to see what all things we need to add in a Docker file, so that it will consist everything which needs to create the Docker image out of our Spring Boot application. And finally we are going to run our Docker image into the Docker container, and we can see we can run it using the respective docker run command and check how it is the image will get run into the container. So let us see step by step. So let us open the Spring Tool suite first, and here we can give our repository project folder. So this is the folder wherein we are going to create our application. Now this is our editor. Now so let me increase the font so that it will be visible. Fine. Now we are going to create one application for employee related application, Spring Boot application, and we are going to add some endpoint using the REST controller. So let us create the application using create new Spring starter project, and here we can use our application name, which is employee. We can give any name, like we can give employee service. Next we are going to select the Maven build type, and here we can choose our respective Java version. We are going to use 21, and here we can add com dot, so it is for employee, so we can use employee package, and we can keep rest of the thing as is. Here it should be the employee project for Spring Boot, and here we can add employee package. Now we can click on next button, and here we need to add all dependency which are required. So first we can add Spring Web. Next we can add, so we are going to use H2 database, so we need to add that. Next we need to add Spring Data JPA. and finally we can add a Lombac dependency for creating the getter setters. Now this much is enough, so we can click on next and we can click on finish. So we are not going to use any other database, so we are going to use in-memory database, which is H2 database, which is a default for the Spring application. Now we can cross check it once for the dependency. So we have all these dependencies you can check, like we are going to use Spring version 3.4.5, and here is our Java version, and these are the dependencies which we have just added. Now here it is showing the red, so let us add HTTPS at the place of HTTP to resolve this, and we can save it. Now first thing, we can create our YAML file. So let me delete this application.properties file, and we can create one new file with name application.yaml. Inside that we need to add entries, like first we can add server.port, and we can give some port, like let's say 8084. Next we can add our Spring application name, here we can give it's an employee service, so we can add employee hyphen service. Next we are going to add data source part, and here we can give the URL name, which is JDBC colon H2 database. It's a in-memory database, and we can give our database name, like we can take any name for creating the database with that name, let's say employee underscore master. Next we need to add driver class name, and we can add driver for H2 database, which is org.h2.driver. Next we are going to add some username, which is let's say dev, and we need to add password. Now for password we can add dev@123. Next thing, we can add the H2 console. We can enable it, enabled as a true, and after that we can add, if you want to check open the H2 console and see the database, we need to add H2 console, so that we can check the database through browser. Next thing, like we need to add JPA part, and for JPA inside that we are going to use Hibernate, and after that we can use like DDL auto as an update. Next we are going to use like show SQL as a true, because we want to see all the executed queries inside the console, so we need to make it as a true. And finally we can add database platform, and for that we can use org.hibernate.dialect.h2 dialect. So this is the dialect for H2 database we need to add. Now let me we need to save it first, and we need to resolve the indentation error which are there. So the formatting should be correct, otherwise it will show the red as it is showing. Now let me open something, and we need to replace like every occurrences of tab with the 2 spaces we have replaced. Now we can copy this and add it. So what we have done, like there was the occurrences of the tab, we have replaced it with two spaces. So we can see here, like we have tab, and here we have added two spaces at the place of tab, so that it will resolve the indentation error, and we can save it. Now it is fine. Now next thing what we can do, we can create the respective packages inside com.employee. Now let us create entity package first. Next we are going to create our repository. Next we are going to create our service layer packages, and finally we can create our controller package. That's it about package creation. Now let us create the respective classes. Like we can create our employee entity. For that we need to add all the respective annotations, like we are going to use all our constructors, no R constructors. Next, like it's data, and after that we are going to use builder, and finally the important thing is an entity we need to use. So we can add all the respective imports for all these, and we need to define what all properties we are going to use. So first we can define some long property which is an ID. Next we are going to use private string name. Next we are going to use private, so this is the employee, fine. Next we are going to use private string email, and next we are going to use some department, like private string department, and we can save it. Now one more thing we need to add for this ID, we need to add ID annotation, which is there inside Jakarta persistent layer. Now next we are going to add like generated value. So we need to define how the auto increment field should get incremented. For that we need to define some strategy, and the strategy here we are going to use generation type, which is an auto. So every time we create a new employee into the database, it should increment this ID by 1. Now we can save it. Now let us create our repository part. Now here we can create the interface for this, like it should be, we can give some name like employee repository, and we can finish. Here we need to add stereotype as an repository, and here it should extends like JPA repository, and here we can mention we have employee, and the ID we can use it's a long type, and we can add the necessary import, and we can save it. Seems good. Next we need to define one interface for service layer. So we can name it like employee service, and inside that we can define like we are going to retrieve the list of employee, and we can define method get all employees. Next we are going to define like we need to provide one create employee method. So for that we can use create employee, and here we need to pass one employee, input employee to be created. It's a new employee we are going to create. We can say new employee. That's it. These two methods are enough. We can add the import for all these. and we can save it. Now this is the interface for employee service. Similar way, we need to add one implementer class which will provide all the implemented methods for this, for the methods which are defined inside an interface. We can give name for this implementer class as an employee service IMPR. Now here it should implements the employee service interface, and we can add service annotation for this implementer class, which is a service stereotype. Now we need to provide the default implementation for all the methods available inside the service. So we can add it and we can save it. Now let us define some we need to inject the repository first. For that we can use auto add, and after that we can use private, like we can use employee repository, and we can add import for this. Next thing, we can add one method. So we have the method here. Now we can call the respective method on this, like we can call find all, which will return all the employees which are there inside the H2 database. We can save it. Similar way, we can return call employee service dot save method to save this new employee into the H2 database, and we can complete it. With this, we are done with our implementer class, which is employee service IMPL. Now finally we can create one controller class with name, like we can give employee controller. For this we can add a race controller annotation, and we need to inject our service layer so that it will use that. So this is the service layer, and here we are going to add some endpoints. We need to add import for this one. We can add one get mapping, which will return all the employees which are there. So for that we can add some endpoint like employees, and here we can use some response entity as an return type. Inside that we are going to wrap our list of employees which will get returned from the service layer, and here we can say retrieve all employees. This is the method name. We do not need to pass any parameter because we just want to retrieve, and here we can call the respective method on the service layer, and here we can use response entity dot OK. Inside that we can call the get all employees method, and we need to add import for all this. Seems good, and we can save it. So this is for get mapping. Similar way, we can add one more method for post mapping, which will allow us to create a new employee inside the database. So here it should return only new employee which we have created, or we can say create employee or add employee, whatever is. Here we can add one request body, and for that we need to pass employee, and this is the new employee which we are going to create inside database, H2 database. Now here we are going to call the respective method, which is create employee, and we are going to pass this new employee inside that, and we can add import, necessary import for all these. So with this we are done with our controller part. So inside controller we have two endpoints. So one is for getting all the employees, and other is for creating a new employee into the database. So this much is enough. Now let us build our application and test it using the Postman, so that we can go with the so let us build it first. Now our application build is success. You can see it here. Now if it is not visible, so I hope so that this is visible to you. Now it's a build success. Now let me run it, or let me show it. Okay, fine. Now let me run it using run as Spring Boot application. Now here we can see this is the message, started employee service application. Okay, now you can see it. This is the started employee service application. That means our application is running fine. Now let us test this application using Postman, so that we can open the Postman. We can add, this is the get mapping, and here we can use localhost 8084. This is our port. Let us check that port as well. And this is the endpoint employee. We can use body raw, and here we can choose the JSON. Now this is the 8084. Why we have taken that? Because in our resource file we have taken 8084. Fine. Now let us test it. So we can hit the send button and check. Now it is showing the empty because we have not added any data as of now. So let us add some data. We can add one name, and for that we can add Ajay, and we can add email for Ajay, like it's ajay@gmail.com, and we can add the department, like which department Ajay belongs to. It's an IT. Now let us we need to change this to post, because we are going to create one new employee into the database. Now we can see we have created one employee successfully. Similar way we can add one more employee. Let us add Suman, and here we can add email address for Suman, and instead of IT we can say it is belonging to the admin department, and we can click on. So we have successfully created two records. Now let us check by calling the get method, and let us check. Seems good. Now it is showing the two records which we have just added. That means our both the APIs are working fine. Now we need to focus on our next step. Now the next thing which is very important we are going to cover, which is dockerizing our application. So while dockerizing the application, we need to first create one Docker file. Inside that we need to define our container, how the Docker engine is going to create a Docker container based on the content which we are going to define inside Docker file. And after that we are going to create one Docker image out of it, and we are going to run into the Docker container. So this section is going to be very important, because we are going to create the Docker file and create the image out of it and run into the container. So let us first create one Docker image. Docker file we need to create. So this is the Docker file, and here we need to add the respective entries. Like first we need to define, we need to use OpenJDK, 21 because we are using the Java version 21, so we need to take the OpenJDK which is 21 compatible with the 21 version. So we can use 21 like JDK hyphen slim. So this is for OpenJDK. Next thing, we need to set some working directory, and for that we can use like working slash here. We can working directory here. We can use what is our working directory. It's a, let's say, employee hyphen service. Next thing, we need to declare some build argument. For that we can define like it's a argument for jar hyphen file, and here we are going to use like where is our jar inside this target folder, which is this one. So we need to mention the target folder, and here it has the jar file with extension of jar. So it has only file which is with extension jar, which is employee service. Okay, so we have mentioned the argument where it can find the jar file. Next we need to define to copy the specified jar file into the image. For that, what we can do, we can define copy so here it should be work directory, fine. Here we can define copy, and here is the dollar, and we can use this is the jar file we need to refer, and after that we need to mention our employee service dot employee hyphen service dot jar file. This is the jar file, it should copy. And next we are going to use the exposing the port. For that we are going to use expose, and port name, let us give the same port as we have defined for our Spring Boot application, which is 8084, and we can save it. And finally we need to define to run the application, run the app, and here we can define our entry point, and inside that we can use our Java interpreter, and this is the hyphen jar command. Next we are going to use our employee service, employee hyphen service dot jar file. So here this is the run the app entry point, this is the Java, this is the command hyphen jar, and this is the actual jar file which will get run. So we have added everything inside this Docker file, we can save it. Now next thing, we can go to the exact location of the employee service so that we can run our commands. So let us go to it here. This is the employee service. Now let us open the command prompt from here, and we can run our Docker commands to build the service. So before this we need to make sure that we are going to build it again. Now we can close this because we have created Docker file out of it. Now let us build this again. Now we can run as maven install. Now we can see it's a build success. Now let us go to our command prompt, and from here we can use the command like docker build, and it's a tag, and we can give our employee hyphen service as a tag name, and here where it should build it at the current location we can add a dot. Yes, it has started downloading or building the image out of this Docker file, and it has successfully created the image. Now we can see on the Docker, inside the Docker desktop, we have employee service, which the image which we have just created. Now it is not in running mode, so let us run the command. So here the thing is, you can run from here as well, or we can run from the command prompt. Now let us run using Docker command, which is Docker run -p to map the container port with our host port, which is 8084, and we can mention what is our service, which is employee -service. Now let us hit it and check. Now seems good. Now we can see the message at here, like it is showing started employee service application. Seems good. Now it is in started mode. Now our Spring Boot application is running. Now you can observe we have not started our application from the editor at local. Rather we have started in a container, and this is running in a container. Now let us check the container and see. Now it is in running mode. It is showing the green in use because it is in a run mode. Okay. Now let us test it using the Postman and see how it goes. Now this is our employee service. Now we have restarted our application, so it should show nothing at here because we have just restarted. Now let us add some entry as we have added earlier. So we can add one name. Let's say we can add one Kiran as an employee, and we can add email for the Kiran, like kiran@gmail.com. Next we can add department to which Kiran belongs to, and which is like operations. Now let us try to send it. So this is the get. We need to change it to the post to create a new employee. Seems good. We have created one new employee with this. Now let us add one more employee, like we can add, let's say, Robert, and we can add a Robert Gmail address, and here we can say the department is computer, and we can click on send button. Now we have created this record successfully as well. Now let us check by calling the get method. It should show the two records which we have just created. Seems good. It is showing the two records. That means everything is working fine where the container is running, and we have called tested with the container running. This is the port of the container, and we have tested it through our local host, and that means everything is working fine. We have tested all the scenarios, like we have created our Docker file and created the image out of it and run it in the container and tested through the Postman. So I hope you must have enjoyed this. I will request you all, so please do not forget to like, subscribe and share. So I need your support to grow my channel. So I will request you, please do not forget to like, subscribe and share. Thank you so much for watching this.